So now we're going to be looking at exponential functions now that we've talked about exponents and radicals, and we're going to visualize what an exponential function looks like on a graph. So first let's talk about what is an exponential function. So an exponential function is not going to be a straight line, it's a nonlinear function in the form y equals a times b to the x. So the exponent is our input. Okay, so what's important here is a is not going to be 0 and b can't be 1. And this is going to give us what we call an exponential function. So you'll see that we're multiplying because we're dealing with an exponent, which is why it's not going to end up being a straight line. And we'll look at the graph later on in the notes. But let's look at how we can identify if we have a linear and exponential function with this first example. So remember, how can we tell if something's a linear function from a table? Remember, we're looking for a constant rate of change. Like, are we adding x by 2 every time? Are we adding y by 7 every time, right? Versus an exponential function. So an exponential function is going to have x increase. So we'll be adding the same number to x, or subtract. But we're multiplying the same number to y. So you see, this is a big difference. For linear, we were adding and subtracting for both x and y. For exponential, we're adding just to the x, and then we should be multiplying the same number to y. Okay, so let's take a look at a and b and see what's happening. So with a, with x, I'm going to notice, okay, this is plus 2, plus 2, plus 2. Great, so that's true for both linear and exponential. Then I want to see what's happening to y. So I'm looking at this y, and I'll see, okay, plus 2, plus 2, plus 2. So this is linear because there's a constant rate of change for x and y. All right, and let's compare that to part B. So if I look at part B, I'm going to check x, plus 1, great, plus 1, and plus 1. So that works out very nicely. And then I want to look at what happens to y. So I can see, okay, this is plus 2, but wait, if I do plus 2 here, then that would be 5. So I'm going to think, oh, what happens if I multiplied? So I did times 3, and look, times 3 gives me 9, times 3 gives me 27. So that works out very, very well. So this is an example of an exponential function. Okay, so it's exponential because you're adding a constant value to x, and then we're multiplying a constant value to y. So you're going to go ahead and, oh, sorry, let's take a look at the you try 1 and 2. Go ahead and try those out, and let's make sure you explain why a function is exponential or linear. Okay, let's go back to example C and D, and you're going to see now I'm giving you an equation rather than a table. And what we're going to do here is we're going to evaluate the function. So you'll see this is an exponential function because x is in the exponent. And what we want to do is basically just substitute in and then follow your PEMDAS, follow your order of operations. So I'm going to take this 2 and plug it in where I see the x. And then we want to go ahead and just use your order of operations. So remember, exponents first, then we multiply. So I'm going to do 4 squared, which is 16. and then multiply that by -3, which is how we're going to get -48. So this is the output for when the input is 2. Okay? So D is the same idea. Here we see x is -3. I'm going to plug that in to where the exponent is. And if it helps to change the decimal into a fraction, you can definitely do that. And I would prefer to do that because I can do exponents with fractions much better than I can with decimals. So it's up to you, but I'm going to change that 0.25 to 1/4. And then again, the exponent here is -3. So just like before, follow PEMDAS, right? Exponent first, then multiply. And remember what we dealt with last time at the beginning of the unit with the negative exponent? That means we want the reciprocal of the base. So I'm going to go ahead and flip that base first to get 4, and then make that exponent a positive now. So now this is pretty straightforward, right? 4 to the third power is going to give me 64. And then 2 times 64 is 128. And there's my final value. Okay, so go ahead and try 3 and 4 for the U-try. Same idea, being careful with your order of operations, and make sure you're noticing I want you to do 3 different values, -2, 0, and 1/2. Remembering this 1/2 as an exponent makes your problem into a radical, into a square root. Okay, let's go ahead and try that and we'll come back and check. Okay, go ahead and check 3 and 4. So one thing I want to note for number 3, when we did the square root of 9 here, we're keeping it as a positive square root because we don't see, you know, a negative in the equation. So like 2 times the negative of 9 to the 1/2 power. So we're going to assume that's a positive, which is why I don't have 2 answers for y. So we're going to keep that a positive 6 instead of positive and -6. And then for number 4, when you did the square root of 2, there's no actual wonderful pretty value for square root of 2, which is why I would actually want you to keep your answers in the exact format, so 1.5 times square root of 2. But if it asks you to round to the nearest tenth or round to the nearest hundredth, we'd want to round. So I rounded to the nearest hundredth down here to get 2.12. Okay, and I just realized I completely skipped going over number 1 and 2. So let's actually go back and check those answers to 1 and 2. Okay, so looking back at 1 and 2, 1 ends up being exponential because you might have thought, okay, y is being divided by 2. Remember, every division can be represented as a multiplication, so this is the same thing as being multiplied by 1/2. So as we add 1 to x, we're dividing y by 2, which is the same thing as multiplying by 1/2, which makes it exponential. Whereas 2 is linear because you'll see we're adding 4 every time to x and then subtracting 1 every time to y, which is the same thing as adding -1. So there is that constant rate of change for both x and y, so that is linear. Okay, so that's going to wrap up the video. We're going to graph tomorrow in class, so please come back with questions.